Hi dear students, in stoichiometry 2 marks question is very important. How many number of moles of glucose are present in 540 grams of glucose? So we know that the number of moles formula, number of moles is equal to weight by gram molecular weight. Weight by gram molecular weight. We want number of moles of glucose. So that means weight of glucose by gram molecular weight of glucose. Weight of glucose by gram molecular weight of glucose. What is weight given? So number of moles of glucose are present in 540 grams. So weight of glucose is 540 grams. What is gram molecular weight of glucose? Glucose formula C6H12O6. So how many carbons? So 6 carbons. Each carbon atomic weight 12. 6 into 12. 6 into 12. 72. Hydrogens 12. So 12 hydrogens. 12 into 1. 12. Each oxygen atomic weight 16. 6 16s. So 6 oxygen atoms, 6 into 16, 96. So total 180 grams. So 540 by 180. So 540 by 180. So 0 cancel. 18 to 54 3 times. So 3. So answer 3 moles. You should write units. If there is no units, so you lost 1 mark or half mark. So formula 1 mark, answer 1 mark. So 2 marks, very important. So next one, calculate the weight of 0.1 mole of sodium carbonate. Again same. So number of moles formula. Number of moles is equal to weight by gram molecular weight. Weight by gram molecular weight. But the question is calculate the weight of. So what is the weight formula? Weight of Na2CO3, sodium carbonate formula Na2CO3 is equal to number of moles into gram molecular weight of Na2CO3, sodium carbonate. So already number of moles are given. How many moles? Number of moles 0.1. So 0.1 into gram molecular weight of Na2CO3. So 2 sodium atoms. Each sodium atomic weight 23. 2 into 23, 46. Next, carbon atomic weight 12. 3 oxygens. Each oxygen atomic weight 16. 3 into 16, 48. So total 106. So 0.1 into 106. So 10.6. So weight is units, in units grams. So answer 10.6 grams. Very easy 2 marks question. Okay. The empirical formula of a compound is CH2O. Its molecular weight is 90. Calculate molecular formula of compound. To solve this problem, first I have to learn 2 formulas. The first one is N is equal to molecular weight by empirical formula weight. Molecular weight by empirical formula weight. So next molecular formula equal to molecular formula is equal to empirical formula into N. Empirical formula into N. So if you learn these two formulas, next answer is very easy. First one, N is equal to molecular weight. What is the molecular weight? Already given 90 by empirical formula weight. Empirical formula is CH2O. Empirical formula CH2O. So its weight is carbon atomic weight 12. 2 hydrogens, 2. Each oxygen 16. So total 12 plus 14, 14 plus 16, 30. So 30. So empirical formula weight 30. So 90 by 30. 3. N value 3. So next molecular formula equal to empirical formula into N. Empirical formula is CH2O. N value is 3. So into 3. So multiplying with 3. So C3, H2 into 3, H6, O3. So the answer is molecular formula of the compound is C3H6O3. So very easy. Next one. Calculate the volume of O2 at STP required to completely burn 100 ml of acetylene. First acetylene formula C2H2. Acetylene formula C2H2. Combustion. Burn with oxygen means combustion. When it reacts with oxygen, it forms. So whatever the alkane or alkyne, when it combines with oxygen or burns with oxygen, forms carbon dioxide and water. So CO2 plus H2O. So how many carbons are there? 2 carbons. So it is multiplying with 2 CO2. So how many hydrogens? 2 hydrogens. So already 2 hydrogens. So here 2 into 2, 4 oxygens. Here 1, 5 oxygens. But here only 2 oxygens. So then it is multiplying with 5 by 2. 5 by 2 into 2, 5. So 5 oxygens. 2 into 2 plus 1, 5 oxygens. So balanced. Carbons, hydrogens, oxygens are balanced. So then it is multiplying with 2, 2C2H2 plus 2 into 5 by 2 means 5O2 gives rise to 2 into 2, 4CO2 plus 2H2O. So the question is volume of O2 required to completely burn 100 ml of acetylene. Both are in volumes. So oxygen, acetylene. Acetylene, how many moles? 2 moles. That means 2 into 1 mole of any gas occupies 22,400 ml volume. 1 mole of any gas occupies 22.4 liters volume. That means 22,400 milliliters volume. So 2 into 22,400 ml C2H2 requires how many moles of water? 5 moles water. 5 moles water means 5 into 22,400 ml of water. 5 into 22,400 ml of water. Question is the volume of O2 required for 100 ml of acetylene is burns. So that means here 100 ml of acetylene burns how much volume of O2 required? For 100 ml of acetylene, how much ml of water is required? So cross multiplication. 100 into 5 into 22,400 cross multiplication by 100 into 5 into 22,400 by 2 into 22,400. So 22,400 cancel. So 2 in 100 50 times. So 5 into 50 250. So answer 250 ml. So 250 ml of O2, 250 ml of O2 required. What is redox concept? Give an example. So what are redox reactions? Give an example. So for example, Zn plus CuSO4 gives rise to ZnSO4 plus Cu. So here zinc oxidation state 0 because it is an elementary form. Elementary form, whatever the atom oxidation state is 0. Here zinc oxidation state plus 2 because SO4 minus 2, Zn plus 2. Cu oxidation state plus 2, SO4 minus 2. Here Cu oxidation state elementary form 0. Zn 0 to plus 2. Zn 0 to plus 2. Increase in oxidation number. So increase in oxidation number. So that's why it is called as oxidation. Next. Cu plus 2 to Cu. Decrease in oxidation number. Plus 2 to 0. Reduction. So it is reduction. So what is the redox concept means? The chemical reaction in which both oxidation and reduction takes place simultaneously. That reaction is called as redox concept or redox reaction. So that means the chemical reaction statement. The chemical reaction in which both oxidation and reduction takes place simultaneously. That reaction is called as redox reaction or redox concept. Statement 1 mark, equation 1 mark, 2 marks. So next one, what are disproportionation reactions? Give example. Very easy. For example, P4 gives rise to PH3 plus H2PO2 minus. That is one example. P4 gives rise to PH3 plus H2PO2 minus. Here phosphorus elementary form. Whatever the atom in its elementary form, oxidation state is 0. Here phosphorus oxidation state, phosphorus X, each hydrogen plus 1, X plus 3 equal to 0. That means X equal to minus 3. So phosphorus oxidation state minus 3. So here phosphorus X plus 2, each oxygen minus 2. X plus 2, 2 into minus 2 minus 4. X plus 2 minus 4 equal to minus 1. X minus 2 equal to minus 1. X equal to plus 1. So phosphorus oxidation state plus 1. Phosphorus 0 to minus 3. 0 to minus 3. It is oxidation number decreases. That's why it is called as reduction. Next, same phosphorus 0 to plus 1. Increase in oxidation number. So that's why it is called as oxidation. Here what we observe, oxidation and reduction takes place. Both oxidation and reduction takes place, but elements. Only same element undergo both oxidation and reduction takes place. So that is called as disproportionation reaction. Here different elements undergo oxidation and reduction, but here same element undergo both oxidation and reduction. So that's why it is called as disproportionation reaction. That means the redox reaction, it is a redox reaction in which same element, it is important, same element undergoes both oxidation and reduction. Both oxidation and reduction takes place. Both oxidation and reduction takes place is called disproportionation reaction. Statement 1 mark equals. So another example is, so another second example for this, 2H2O2 gives rise to 2H2O plus O2. So here oxygen undergo oxidation and reduction. Here O, peroxy linkage, -1 to -2 reduction, -1 to 0 oxidation. So second example, 2H2O2 gives rise to 2H2O plus O2. Okay, not this one. So assign the oxidation numbers to the underlined element. So here underlined element is manganese. So potassium, first A group element. For first A group element is sodium, potassium, rubidium, cesium. Always oxidation state is +1. So potassium +1 plus manganese X. Manganese X plus each oxygen always -2 in oxides. So 4 into oxygen -2 equal to 0. So X plus 1, 4 into -2, -8 equal to 0. So X is equal to -8 plus 1 -7. So right side +7. So X is equal to +7. Manganese oxidation state is +7 in KMnO4. Next K2Cr2O7. So chromium, potassium +1, 2 potassium atoms, 2 into +1 plus 2 chromium atoms. So 2 into chromium X, X plus 7 oxygens, 7 into each oxygen -2 equal to 0. Sum of the oxidation states of all the elements in a molecule or compound is equal to 0. So +2 plus 2x minus 7 into 2, 14 equal to 0. So 2x minus 12 is equal to 0. So 2x is equal to 12. That implies x is equal to 12 by 2. 12 by 2 means 6. So oxidation state of chromium is 6. Next, MnO4 minus 2. It is a compound. So that's why sum of the oxidation states is equal to 0. But it is an ion. In ion, sum of the oxidation states of all the elements is equal to its charge. So manganese X plus each oxygen -2. So 4 into -2 equal to its charge -2. Sum of the oxidation states of the elements is equal to its charge. X 4 into -2 -8 equal to -2. So X is equal to -2 plus 8. So plus 6. So oxidation state of manganese is 6. So next Cr2O7. How many chromium atoms? 2. So 2 into X plus each oxygen -2. 7 into -2 equal to its charge -2. 2x minus 14 equal to -2. So 2x minus 14 right side plus 14. 14 minus 2, 12. So 2x is equal to 12. X is equal to 12 by 2. So 12 by 2 means 6. So oxidation state of chromium is 6. Next, C6H12O6. Glucose or fructose. C6H12O6. Carbon. Oxidation state of carbon. 6 carbons. That means 6x plus each hydrogen oxidation state +1. So 12 into +1. 12 into +1 plus each oxygen -2. So 6 into -2 equal to 0. 6x plus 12. 6 into -2 -12 equal to 0. -12 plus 12 cancel. 6x equal to 0. So that means x is equal to 0. Oxidation state of carbon in glucose or fructose is 0. So next, very important, H2SO5. If you calculate it directly, +2 plus x minus 10 equal to 0. So then sulfur oxidation state is +8. But sulfur highest oxidation state is +6. That's why first we have to learn H2SO5 structure. It is peroxysulfuric acid, corrosive acid. Peroxysulfuric acid. It is also called as corrosive acid. So its formula is S double bond O double bond O OOH OH. So H2, yes, 1, 2, 3, 4, 5. Oxygens 5. So here peroxy linkage is present. In peroxy linkage, oxygen oxidation state -1. Here -1, here -1. The remaining all oxygens -2. So then two hydrogens. So then two hydrogens, 2 into plus 1 plus sulfur X plus 1, 2, 3. 3 oxygens -2. That means 3 into -2 and 2 oxygens 2 into -1. 2 into -1 equal to 0. So 2 plus x 3 into -2 -6 -2 equal to 0. Plus 2 -2 cancel. X minus 6 equal to 0. So that implies x is equal to plus 6. So oxidation state of H2SO5, sulfur in H2SO5 is 6. Next, H2S2O8. H2S2O8. S double bond O, S double bond O, double bond O, OH, double bond O, OH. So 1, 2, 3, 4, 5, 6, 7, 8. 8 oxygens, 2 hydrogens, 2 oxygens. Here, 2 oxygens are in peroxy linkage, OO linkage. So -1, -1. Remaining all oxygens are -2. So 2 hydrogens, 2 into plus 1 plus 2 sulfurs, 2x plus 1, 2, 3, 4, 5, 6. 6 oxygens -2. 6 into -2. 2 oxygens -1. 2 into -1 is equal to 0. So plus 2 -2 cancel. 2x minus 12 equal to 0. That implies 2x equal to 12. X is equal to 12 by 2 means 6. So oxidation state of sulfur in H2S2O8 is 6. Very easy. So first we have to learn H2S2O8, peroxide disulfuric acid. Disulfuric acid. It is also called as Marshall's acid. So very important structure. So next one, CrO5, chromium pentoxide. It has butterfly-like structure. Cr, double bond O, O. So butterfly-like structure. That means 4 oxygens are in peroxy linkage. That means 4 oxygens are -1 oxidation state. 1 oxygen is -2 oxidation state. Chromium X plus 4 oxygens, 4 into -1. 1 oxygen, 1 into -2 equal to 0. So x minus 4 minus 2 equal to 0. X minus 6 equal to 0. So x is equal to 6. So oxidation state of chromium in chromium pentoxide is 6. Calculate the normality of oxalic acid solution containing 6.3 grams of oxalic acid in 500 ml of solution. So already given values, normality, calculate normality. What are the given values? 6.3 grams. And the weight of oxalic acid. Weight of oxalic acid is 6.3 grams. Next, gram molecular weight. What is gram molecular weight of oxalic acid? Gram molecular weight of oxalic acid. If you calculate all atomic weights in H2C2O4 to H2O, so 126 grams. If you calculate total atomic weights in H2C2O4 to H2O, 126 grams. That is gram molecular weight. So next, what is volume is given? Volume of solution. Volume of solution is 500 ml. So 500 ml. So then the normality formula. Normality is equal to weight by gram equivalent weight. Weight of solute by gram equivalent weight of solute into 1000 by volume of solution in milliliters. It is the formula. So weight. What is the weight is given oxalic acid solute 6.3 by what is gram equivalent weight? Gram equivalent weight means it is acid. For acids, gram equivalent weight is equal to gram molecular weight by basicity. Again, what is basicity? Basicity means number of replaceable H plus ions. Number of replaceable H plus ions in oxalic acid is neutral. So in H2C2O4, number of replaceable H plus ions 2. So that means 126 by 2. Gram equivalent weight is equal to gram molecular weight by n factor. N factor means for acids basicity. Basicity means how many replaceable H plus ions are there? 2. So gram molecular weight is 126. N is 2. So 126 by 2. 126 by 2 means 63. So here 126 by 2, that is 63. 63. So 63 into 1000 by volume of the solution already given 500 ml. So 500. 500 in 1000 2 times. 6.3 in 63 10 times. 2 by 10. 2 by 10 means 1 by 5. 1 by 5 is equal to 0.2. 0.2 capital N. Units important. If there is no units, you lost half mark. So 0.2 capital N. Simply capital N or gram equivalents per liter. Okay, next. Calculate the molarity of NaOH solution prepared by dissolving 4 grams in enough water to 250 ml of the solution. So already calculate molarity M. NaOH solution prepared by dissolving 4 grams. So weight of NaOH is 4 grams. What is gram molecular weight of NaOH? Sodium 23, oxygen 16, hydrogen 1. So total 40. So next, volume of the solution. Volume of solution is 250 ml. So 250 ml. Molarity M is equal to formula weight by gram molecular weight into 1000 by volume of solution in milliliters. So weight, what is the weight is given? 4 grams. So 4 by gram molecular weight of NaOH 40. 4 by 40 into 1000 by volume of the solution 250. So 250 in 1000 4 times. 4 in 40 10 times. 4 by 10. 4 by 10 means 2 by 5. So 2 by 5 means 0.4 capital M molarity or moles per liter. 0.4 molarity or moles per liter. Okay, not this one.